Let's take a look at the transition metals. The transition metals in the periodic table are found right here in the middle from group number 3 to group number 12. We have a lot of familiarity with the transition metals because we know some of them. We have actually touched many of them, like iron and gold, for example, or even copper in wires. So there are many of those that we can see in daily items. These elements are very special as well, and they are called transitions because there is something particular in their electronic structure that it is not for this a course, but eventually in advanced chemistry courses, you will see that it has to do with the transitions of electrons. For now, we're going to be learning that these transition elements, they tend to have higher densities as well as higher melting and boiling points compared to the reactive metals or group number 1 and 2. So here, in this diagram, you can see an illustration. You know, a little piece of gold would be enough to make up for the mass or the weight of like a big block of magnesium. Magnesium is going to be lighter than gold, and then the density is appreciated here in the volume that it occupies right here. The melting points and other trends in the transition metals is not as clear as we see it with the group number 1 and group number 2 elements. But generally speaking, you just need to remember that they have higher melting points and boiling points, as well as higher densities. As well, generally speaking, the reactivity is way lower than the reactivity of the alkali and alkaline earth metals. This reactivity is seen that, or as an example, is that we can find the elements free in nature. So we can find pieces of gold, we can find pieces of platinum, pieces of silver free in nature because they tend to have very low reactivity. Even, for example, in order to melt gold in regular acid, it will not happen. There must be a special mixture of acids that is called aqua regia in order to dissolve gold. Other than that, you can put a gold in regular acid and it will not dissolve. So, because some of them they tend to have really low chemical reactivity. Because of this, they are used as well in replacement of joints, for example, in the human body, because they cannot put a metal that will react or will decay or rust in the body. So they need to put a metal that is light and also that has very low reactivity. That could be, for example, titanium, and that's why it is used to replace different bones or joints. These transition elements also they have the similar characteristics as the other ones. They tend to be gray and shiny. Some have special colors, like for example copper. You can also see gold that has a special color. But generally speaking, you know, all of the metals they are silvery gray and they have metallic luster. These some of them can also work as catalysts, so that means that they can speed up chemical reactions. The most common example of a catalyst is a platinum. And as we know, the groups elements in group number 1, they when they release the electron, they have a charge of +1, and that's the only one. In group number 2, it is +2. However, transition metals, some of them can have multiple charges or oxidation states. And as well, compounds of groups number 1 and 2, they tend to be white. Like if you remember the calcium carbonate, it tends to be white, or sodium chloride as well, it tends to be kind of white. However, the transition metals, they tend to form color compounds. Here we can see some examples of potassium chromate or dichromate. It's kind of orange. Then iron sulfate, this kind of a green or blue, cobalt chlorides, and they tend to have really, really nice colors. So just to sum up, let's see a question related to this one. It says copper is a transition element. It can have variable oxidation states, as we know. State two other chemical properties of transition elements which make them different from group 1 elements. So chemical properties of this one, so you can say that they have very low chemical reactivity compared with the transition, group number 1 and group number 2 elements. And also in terms of other chemical properties is that they form compounds with colors or color compounds. That's another one. Also, there is another one, like, and it's mentioned right here that because of they have variable oxidation states, so the same element can form compounds with different colors because each oxidation state or charge will give a different color. Now let's take a look at the second question right here. Which of the following could be a transition element? So let's analyze this one right here. It has a melting point 114, 60, then 1000, 3000. Then these two could be transition elements because they have high melting points. Then let's look at the density. Then this one has a high density compared to this one, gray and black, so the color doesn't really have much to do with it, but they tend to be gray. And electrical conductors, yes, so they have to be an electrical conductor. So in this case, the one that fits everything for a transition element would be C, because it also has high melting point and high density. This one has a high melting point, but the density tends to be lower. So, and then the color here is black, but then remember that the metals, they tend to be gray or silvery.